Okay, let's look at the homework 3.3, number 5, right? So we need to discuss the concavity of this given function, right? So let's take the derivative, right? So f prime of x is equal to, right? So since it's a multiplication of two things, x and the quantity 12 minus x squared, so we're going to use the product rule, right? So derivative of the first is 1 times the second, so it's a quantity 12 minus x squared, right? Plus, right, first guy, so x multiplied by derivative of the second. So put 2 in front, keep the same quantity, so 12 minus x, and subtract 1 from the power, so it's 1. Then multiply by derivative of inside. Derivative of inside function is -1, so we have -1, right? Then so try to simplify that. So you're gonna have, let's see, so what's in common, right? So it looks like 12 minus x is in common, so I'll circle this, and so circle here to indicate that I factored out 12 minus x already, right? Then what's left is here, right? So there's another 12 minus x sitting here, so it's a 12 minus x, right? And from the second term you have a negative 2x, so negative 2x, right? So you can see that we can clean up a little bit more. So you have 12 minus x. Right here you have 12, then combine negative x and negative 2x, so negative 3x. Right. Then we can pull out actually 3. 3 is in common, so pull out the 3. And 12 minus x. And 4 minus x. Alright. And I would probably try to multiply this guy by -1 and this guy by -1 that way, or pull out the negative sign from here so that it looks a little bit better. So I'll write it as 3, and instead of 12 minus x, I would write it as x minus 12. So I'll pull out the negative sign, right? Then I'll do the same here. So we'll pull out the negative sign twice, so it turns into positive. So you have x minus 4. Right? So that's our first derivative. Alright, let's take another derivative. So f double prime of x. Right? So 3 is in a constant multiple. Right? Then take the derivative of the first, so that's going to be 1, and multiply by second, so which is x minus 4, plus first guy is x minus 12 times derivative of the second, which is 1, right? So if you combine that, you have 3 times, right? So x plus x, so you have 2x minus -4 plus -12, so -16. Right? So we can pull out the 2, so it's going to be 6 here because 3 was already there. So you have x minus 8. Right? Right, then we can set that equal to 0 to find the x coordinate of the possible inflection point. So let's see, so it's going to be, you can see that x equal to 8. Right, so we'll draw a number line to determine the concavity. All right, so here's the x-axis. All right, so I'll put 8 right here. Right, then we just have to look at the sign of the second derivative. Right, so we try anything smaller than 8. So I like 0, so I'll try f prime double prime of 0. Right, so if you plug in 0 here, you can see that that's going to be negative, because 0 minus 8 negative, and 6 is definitely positive, so this is going to be negative here. Right, and if you plug in anything larger than 8, so plug in 9, then you can see that the 9 minus 8 is positive. All right, so if on the interval from negative infinity to positive 8, we know that sign is negative, so it's f double prime less than 0. Then therefore, so second derivative negative, you have a concave down shape, right? When on the interval from 8 to positive infinity, second derivative is positive, right? Then concavity is second derivative positive, so you have a concave upward shape. All right, that's it. I hope that this was clear.